Hello, and thank you for listening to this episode of the Night Sky Podcast for the third week of January 2016. This week, I'm joined with Marina Hanson once again to talk about some of this week's star and sky watching news and events that are coming up. And want to introduce you now. How you doing, Marina?
Hey, Billy. I'm doing well.
Cool. I'm glad that you're here today again with me to talk about some of the cool stuff that's coming up. I think it's been it's kind of a slow period right now. In January, in this midsection of January. And then it's going to start picking up a lot at the end of January. And then I think if we get good viewing, at least in the Northwest here, I think it's really going to ramp up for us through February and March. And then really almost all of April, May, June, and all through the summer have a lot of different events going on that are kind of interesting skywatching things that we'll be able to keep track of. But I think it's a little bit of a lull right now.
Yeah, I'm excited for the things coming up in the next few months.
Yeah.
Right now it is pretty slow.
Well, I could say it's slow. And then I could say that, there's like 4 planets visible in the AM.
That's really
pretty
cool.
I guess.
We'll have the 5th one soon.
Yeah, even as I think it's just a lull because there's going to be a 5th one soon. So that's when like the highlight comes in. That's when the news is, the headline.
Yeah, the 4 planets being visible is really cool.
Yeah, so right now in the AM, and we've been kind of observing this the last couple nights when we've had a couple clear nights in the breaks of all these El Nino storms that keep sweeping through the West Coast. We got a couple clear nights during the last week, separated by about 5 or 6 days. But I think the first night we got to see that observation, I think it was the 9th, where Saturn and Venus were like just a half a degree apart from each other in the morning sky. They were just right up next to each other. That was really cool. Do you remember that? It was like maybe a week and a half ago.
Yeah, I remember that.
Yeah, really cool to see. And then that was like, that's in Scorpio, because Scorpio is now in a helial conjunction in the morning sky. So I think a helial conjunction, and this might be the wrong use of the term, but what was explained in the way that things were written about, I think this is astrologically. Helial conjunctions are the first constellation that rises above the sun in the morning sky. So it'd be the last constellation to rise above the horizon before the sun comes up. Does that make sense? So it's the first constellation you see at first light.
Right.
That's the helial conjunction sign. And so that's what some astrological systems or some calendar systems would use as their position to identify the constellation in character at that time. So you know how some people maybe complain sometimes that the month that Sagittarius occupies the sun is not the month that the zodiac identifies for your birthday. Right. And so the reason for this disparity sometimes culturally was because it was identified through a helial conjunction of that constellation instead of the other type of conjunction. I think just a regular conjunction, or when the sun is absolutely in that constellation. Mm-hmm. So in this thinking, it's the sun is now past that constellation, is now probably in another constellation, but it's that constellation that we see at first light when the sun just starts to come up. That's the one that I think they would count sometimes. Now that doesn't really even break down or make things make a lot more sense astrologically, but for astronomy, I think it's just kind of interesting to think about the different ways that people thought about how they list or identify what the constellation at that time of the year was.
That's really interesting.
Yeah, and so because Scorpio's in that helial conjunction, it's that first star, or the first constellation up over the horizon before the sun then finally rises. That's where Saturn and Venus are right now. And then we're going to see Saturn. What's that?
Oh, I was saying that's right.
Yeah. So, Saturn and Venus right there near the heart of Scorpio. And so I think Saturn, this is going to be interesting to watch, and we'll see it throughout the year too, is Saturn is going to stay right where it is in Scorpio. And that's because Saturn has such a long orbit. It's like a 27-year orbit versus Mercury's 88-day orbit, Earth's 365-day orbit, Mars's 400 and something orbit. I forgot what I remember reading or what I remember watching in The Martian. It's like the number of souls on Mars.
Yeah.
It's like 460 or something like that. They have like a 25-hour day on Mars because the day is marked by like how long it rotates. So it doesn't really have to even be that close to what Earth is. It's just interesting that it's like that, but it's a little different. It's weird how per world, everything is going to be different. It's strange. So we're going to see Saturn stay at the heart of Scorpio through the rest of the year because it has such a slow orbit, where we're going to see Venus move around a lot in relationship to the sun and the sky. And so that's what we're going to get to see is Venus and Saturn start to separate away from each other. And then Mars in retrograde, which is now in Libra, is going to be in retrograde until the end of May. And we're going to see it drop backwards in the sky past Virgo and Spica, and then drop into Scorpio, and then stop retrograde right when it gets right up next to Saturn. And then we're going to see it move out past again, and then back in close to Saturn, and then continue on into like Capricorn and Aquarius throughout the rest of the year. But it's going to be really strange. I think what we talked about on the podcast before, how Mars is going to be in retrograde for maybe the next like 13 or 14 months. It's going to be up in the night sky, which is really strange. It's going to be in the night side of the Earth for maybe like 15, more than a year, which is way more than what we normally see. Yeah. But it's cool. And that's kind of the cool observational piece about Mars is its relationship in orbit to the Earth, and then where we can kind of see it in the sky. So we're going to see it move a lot this year, and we're going to see it grow in brightness a lot too. And that'll be really fun. But for next week, we're going to finally see all 5 planets in the sky at the same time. There's some times of the year where you can, through the 24-hour period, you can identify all 5 planets. Does that make sense? Like maybe 3 planets are up at sunset, but if you stay up till 4 in the morning, you'll see Jupiter rise, and then you'll see that next planet. Yeah. So you'll see the whole total throughout the day. In fact, I mean, obviously, all 9 planets pass up above us in the sky and then set past us in the evening every single day, right?
Right.
Because they're just always there. But we can't really observe them all the time, or they're in the place where it is daytime for us, or they're in from the sun toward us. So we can only see it when, I think it'd be where the planet is at a position of opposition to the sun. So it is on the dark side of the Earth. It's past that meridian line of day night. And so we can look out and see the planet out there while it's not daytime.
That is really interesting. So when is it that we're going to see, or that we're going to start seeing all 5 of the planets together at the same time in the sky now?
Yeah. So we have 4 up in the morning sky right now. Mm-hmm. And then Mercury has just made its path. So we saw Mercury, we talked about Mercury being visible and on the rise at the end of December in the evening sky.
Right.
And now Mercury at the very beginning of January, I think by January 7th or 8th, it had dropped back down past the horizon. And then it passed the sun, and then it has such a fast orbit and is in a position right now where it's just going to be visible really quickly on either side. Normally it's not this easy to see Mercury. It's swung past the sun it's swung past the horizon in the evening sky, and it's now going to be coming up in the morning sky, I think on January 20th. So on January 20th is going to be the start of the period where we're going to be able to see all 5 planets at the same time. It might be a more difficult observation than some other times, because Mercury might be, for this period, really close to the sun, or really close to sunrise. So it'll be just the last few minutes you can still see stars in the sky, at least for the first few days, until it rises up a little bit further into the nights or the morning twilight sky.
That's cool. That's just a couple days away.
Yeah, it's just a couple days away. And I think it's going to last into the first couple weeks of February, while you can still see all 5, or while you can still make an observation of Mercury along with the other 4 planets that are up. And I was thinking about this. I was thinking about the last time that this happened, and really kind of how rare it is often. I think it's happened, let's see, what was it? I think it happened in 2005. That's the last time that it happened. And it was also in the morning sky that you could see all 5 planets at the same time. And then the time before that it happened was in, I think, the springtime of 2003, where you could look up and you can see all 5 planets in the night sky at that time too. So it's been, I guess, more than a decade now. Yeah. More than a decade now since all 5 of them have been visible at the same time. So it'll be really fun to get a chance to see. Yeah,
that's cool. It's interesting that there's all that time between, or that there was just the 2 years between 2003 and then 2005, and then it's been 11 years now. It's 2016.
Yeah, it's strange. It's really surprising how few times it happens in history that the planets align up so that they're all in one section of the sky at a similar time. It's really strange. It's kind of curious how it is. It's cool when even we just get to see 2 planets in a close relationship to each other. That, as we'll kind of come to find year over year over year, is really sort of a rare thing. I mean, I guess it happens maybe a couple days a year. And that's, I think, why the ancients kind of took it in as sort of a significant sign, right? Like a prophecy is kind of put down or made mention of, because that's the thing everybody's going to pay attention to when they're looking up.
Yeah, that'd be pretty interesting to see.
Yeah.
It'd cool. Seem important. or significant.
Yeah, I'm sure it seemed pretty important back in the past. So I was looking at a few other things that are going on, and I think that the planet observations that we're going to be able to make in the end of January and February, they're going to be the coolest thing that we're going to get to do for a while, and kind of tracking the motion of the planets is going to be cool. But right now, it ends up being a really good time if we have dark and clear skies. It ends up being one of the best times to view Andromeda, which is the nearest galaxy that is not the Milky Way out there in space from us, I believe. Or I think it's perhaps also one of the easiest to view. It's the Andromeda Galaxy, and it's in our local group of galaxies. So there's a few galaxies there are a few galaxies out there that are all kind of collected together in a bunch, and then there's large amounts of space in between that out in the universe. Really strange how that works. I don't really have any perception of the geometry or geography of galaxy over galaxy over galaxy. But what we can do in the night sky when we look up with a telescope or binoculars, you can find the Andromeda Galaxy out kind of in between Pegasus and the constellation of Cassiopeia. So there's a little trick to finding it. You should look it up online, but there's like 3 stars that you sort of trace out from Cassiopeia toward Pegasus, and it's like 1, 2, and then the third, and then you drop down just a little bit. And you can like see it just barely on a really dark night. You can see it with the naked eye. And it's like just barely a fuzzy bit of a speck. And it's a whole other galaxy. It's really cool.
That's cool. Are galaxies measured by magnitude also? Or how would that be? Because I guess it's a lot of stars that are...
Yeah, they would do something like that. They probably identify it.
How would the Andromeda Galaxy be measured then? Or what would it be compared to the stars?
I think it's a 6th or 7th magnitude item, but I think it's probably around there. It's at the limit of visual acuity.
Barely see it.
Yeah, it's one of those things you can barely see through binoculars. You could do pretty well to see it, and I think through a telescope you could do really quite well. And the reason that this time of year is better is because it's passing over the zenith point in the sky, and while we're at midnight, midnight. That's why we call it midnight. While the sun is on the other side of the earth, while the part of the earth that we're observing from is at its darkest, we can look straight up, which is better because, when you look low on the horizon, that's why we see sunsets. We see all that murky smoke and smog, all that atmosphere we have to look laterally through. But if we look straight up, there's really only 5 miles until the end of most atmosphere that we have to try and get through. And so that's why they say that this is one of the better times to make a viewing of Andromeda, because if we have dark skies at night, it's just going to be straight overhead, and you can make an easier observation of it early in the evening. But it'll be cool. I think it was first, what was identified a long time ago. They'd catalog almost every kind of visible speck that they could see in the night sky, well before they were really able before they were able to technically identify the characteristics of it. So they didn't know it was a galaxy. They didn't even believe in galaxies until Hubble proved it in 1927, I think is what it was.
Oh,
I think
that's
that was
really
the first,
interesting.
Yeah. So for the longest time, there was really no universe construct in society or in the understanding. I think even the idea of having a galaxy outside of the solar system, but having a galaxy to sort of interpret why there are all these stars around us in the first place is really sort of a modern idea. And then the idea of the whole universe and multiple galaxies and multiple millions and millions and billions of stars in different groups out there was just sort of unfathomable for the longest time. So I think what Hubble was able to do, he was able to measure that it was a certain distance away for the first time by using observations. It was really interesting because galaxies are tricky. This might be over my head. It's way over my head. I don't know anything about how to measure the distance to a galaxy, but Hubble was the first person to identify in 1927 that the Andromeda Galaxy mathematically was provable to be millions of light years away instead of thousands or tens of thousands, and that it was a huge group of stars. And that would be like a whole separate galaxy. I think for a long time, they maybe considered it to be just a star cluster, a grouping of stars that was out there. And then they were later able to find out that it was super, super far away. I think like 2 million light years. His estimates might have even been low for the time. And then I think, what is it? I think I'm trying to figure out the best way to explain it. The idea of identifying the distance to a separate galaxy was through the use of standard candles. There's this term that they use for it, or at least the term that my old textbook says for it. Or Cepheids, I think, is also the other idea. And so it's these super bright pulsars that have a variable magnitude of brightness to them during a period of time. So like 18 days or 90 days. It's a star that goes through a pulsating phase where it gets dimmer and then a lot brighter. And I kind of understand through this that if... This is the tough thing. And it's kind of a thought experiment to figure out. But if there is an item that we have right next to us, that we know the absolute amount of light being emitted from that item, and then we have a duplicate exactly of that item, maybe a mile away from us, and it's the same exact light that's coming from both sources, but we identified that the one a mile away from us is much dimmer visibly to us, right? Does that kind of make sense?
Yeah.
Still? And so what we're able to do mathematically is figure out the luminosity apparent to us from the candle that is right next to us. And then by the inverse square law, we're able to estimate, basically, I believe estimate, but really scientifically and mathematically, it's appropriate. The inverse square law shows that the dimmer light that is essentially the same amount of light must be so much further away to appear that visibly dimmer. Does that make sense a little bit?
Yeah.
So they're able to do this by identifying really specific bright spots in our galaxy that are far away, a standard candle here that we know the light of. And then we're able to identify, fortunately, and this is through the work of Hubble early on and why we have like the Hubble telescope and why it does so much research in looking at all these other galaxies that are really far away, is we're able to figure out we have Cepheid here, our pulsar, here in our galaxy. We know the standard candle light of that. And then we've been able to identify one also in Andromeda. And then through the inverse square law, we're able to prove scientifically that it is millions of light years away from us. That's really, really far. Really strange.
Yeah, that's really interesting.
Yeah, a lot of fascinating stuff that they used scientifically to identify sort of the stuff around us. A lot of it's sort of a construct. And it's like, it's really difficult. See, with stars, we use parallax to identify how far away another star is.
Sure, yeah.
And so like if you put a finger out in front of your face and you have one eye closed, and so just your right eye open, and then you switch to just your left eye open, if you kind of pay attention to the background past your finger that you're sort of focusing on, you'll sort of see a shift in it, a degree shift. And that's a little bit of a demonstration of what parallax is. It's that my view of observing you is sort of relative to an object that's going to be in front of it.
Right.
And so that's going to shift as I move throughout the year. And so what we're able to do is take a measurement of, let's say we look out at Sirius, a fixed position. It's a star. It's going to be out there. It's been there for a long time. And we know that it's 8 light years away or so. I think it's like 8.16 or more or whatever it is. So we look out and we see Sirius. We identify it's 8 light years away, but how? And that's because we're able to identify the shift of things that are much further away from us. Okay. So if there's a star right directly back from Sirius that we're able to see in like a deep sky telescope where it's really dark and we can identify things that are further past us, we can take an observation in June and then keep that observation until we get all the way down into December, let's say, when the Earth has moved from one side of its orbit all the way around the sun to its far side of the orbit, if you were to think of it that way, which is going to be the most distance, the whole diameter of its swing of an orbit. Does that make sense?
Yeah, that makes sense.
Then they take another observation of that same position, and they're able to identify the shift, the parallax shift that happens of the 2 stars. And so we see one kind of move out of its way. If it moves more, it means it's closer. If it moves less, it means it's much further away.
Right. Makes sense.
And so they're able to use this and a lot of other complicated systems that are really pretty intelligent. And they're able to use this to identify how far all of these astrological bodies are away from us.
That's really cool.
Yeah, it is really cool. It's fun learning about that. I remember like my astronomy teacher showing us and kind of talking to us about how all that stuff works way back in high school. But it's cool kind of thinking about it again and like learning about and looking back into this book too about like all these different things like standard candles and all this sort of stuff. All these sorts of crazy things that they've made just in the last 100 years to identify how everything works in the night sky.
Yeah, it's really interesting just how recent those things you're talking about are, or were starting to be used.
Yeah, it's so recent. Just like the whole construction mentally of what we think of as the Milky Way and the galaxy and the solar system, all of those sorts of ideas are really only a few generations old.
Yeah, it's crazy that the idea of galaxies being a thing is not that old of an idea. I hadn't realized that it was so recently, really.
If you were a superstitious native, I mean, how would the concept of a galaxy ever even present itself?
Yeah.
Really, or, when you think about the greatness and the immense amount of space that's out there, I think the belief was it was sort of homogenized, that just out into space, it would just kind of continue on like the galaxy, I guess, forever, or through the limits of the universe that was kind of controlled. It was small, it was sort of contained. It's really cool, though. It's really fun to kind of get to like read about and then understand like how they sort of came about those revelations, and that we can go and do some of that science ourselves too. If we want to go out and take a look at Andromeda, we can observe something that even only recently we've just found out is 200 million light years away from us. I was also reading too, it's on a collision course with the Milky Way galaxy. And so they say that, the universe is 14 billion years old, give or take. And then in 10 billion years from now, we'll be at a position where the Andromeda galaxy and the Milky Way galaxy are intersecting each other in space. Possibly. There's a probability that will take place. Angles and such and time and our brief amount of, like we were just talking about, we didn't even know it was a galaxy 80 years ago.
Yeah.
So it might miss us too. But what I hear, and the fascinating thing, really like a miracle, is that two galaxies can run into each other, and the probability that any two large solar masses, like a star or a cluster or something, will interact with each other, will slam into each other, is almost zero. There's so much empty space in between each solid object that two galaxies could cross into each other and not ever actually collide any physical material with each other.
That's crazy.
Yeah, but the gravitational relationship between the two bodies would really be shared quite a bit. Mm-hmm. And so it'd be kind of like centrifugal force, or if you think of something like, well, I guess just kind of a simple understanding of gravity, just the two bodies are going to be associated with each other now, and then they'll start to orbit each other just a little bit, and then they'll still kind of continue to separate. So there'll be kind of a drag as they pass through each other. Stars from one galaxy will be caught in the gravity of another galaxy and stay with it.
Sure.
And then other parts will be kind of left alone, but it'll be kind of the string that's sort of split out as the two kind of come into contact with each other and then separate from each other. But that's 10 billion years from now. It's quite a ways out. I think it's 5 billion years after our sun goes extinct. And that's the other interesting thing about the whole idea too, is that 10 billion years from now, many of the stars that we see in the sky tonight will be gone. They'll have exhausted most of their helium or their hydrogen, and then probably their helium. And then if they've gone extinct, they're going to be a fourth or then fifth or sixth generation star. And as the universe gets older and older, there's going to be less and less free hydrogen available. And so as those elements get fused into heavier and heavier elements, there's going to be, I think, fewer and more dense stars. They're all going to be like helium or carbon star. It's really strange. I don't even know how that sort of stuff works. My understanding of anything past main sequence is like super limited. But it's really strange though, because like billions of years from now, it's all going to be these really heavy metal or heavy elements that are left, and that's what's going to be fusing together. And these galaxies are going to be kind of coalescing or cannibalizing each other. And one of the models of the universe is that over the next many billions of years, if things keep going the way they do, that all of the matter in the universe will sort of coalesce and come back together, or sort of collapse back together, like through the cannibalism of the two galaxies between each other. Those galaxies will merge, and then that in billions of years later will merge with the whole local group, and that will merge with the next large local group until there's a big crunch where all the matter kind of comes back together and is kind of fused or stuck together after the Big Bang. So the Big Bang blows it all apart, and then the crunch is its coalescence 100 billion years later of all the matter coming back together and being cold and fused. And then perhaps it would happen again. Or that's just an idea that, has had some legs, but there's so many different ideas of how the universe is going to come together or work. It's really cool. It's fun. Some cosmology stuff though. I guess for us, it's more about just what we get to go see. And the other thing we get to go see, the last thing on our list this week to talk about, and it's pretty cool too, is the Occultation of Andromeda. Were you reading about this?
A little bit, yeah. It's going to be passing in front of, what star is that?
What did I say? Did I say Andromeda? I'm sorry. The occultation of Aldebaran.
Yeah, Aldebaran.
The moon in front of Aldebaran. Thanks for correcting me. I appreciate it. So Aldebaran is the bright star, the orange giant that's in Taurus. It's sort of the head of the bull horns is sort of the idea of it. And then the Pleiades is sort of the end of the tail of Taurus. But yeah, Aldebaran's there. The moon, I think, is going to be 80% full, and it's going to pass in front of, for most of North America, it's going to pass right in front of, I think, the dark arm, the dark sliver, which is going to be cool to see. The dark sliver is going to occult Aldebaran for a period of time. I think there's a small window, and you have to be exact and specific to your local area because the moon kind of moves sort of quick through areas. But it'll be probably a good amount of a few hours, perhaps. But it's cool. Yeah, it's going to pass over Aldebaran, so you won't be able to see Aldebaran in the sky. And it's happened a few other times before. I think it happens with planets sometimes. I think every once in a while the moon will occult Jupiter. It'll pass right in front of Jupiter, which is a cool type of sight to see, because it's just a planet disappears out of the sky. Yeah. Or for this, even just seeing a star disappear out of the sky is kind of a cool thing. It happens really quite rarely. It's sort of interesting to see how the moon's ecliptic sort of moves throughout the year. It's not an exact absolute position. And the Earth's relationship, its tilt of an axis, and the moon's relationship kind of causes everything to be just a little different and sort of cycle through this long kind of complicated series of events. Strange, or just for observations for us, how it doesn't happen all the time. And it only happens certain times. I think it happened back in October for a short period of time.
What did it pass over in October?
I think Aldebaran that time also.
Oh, okay.
It's right in the line. So it will have it happen to it. Oh shoot. What's the other one that's out there? I'm trying to think of the other stars that I've seen close to being occulted before. I think occult is a cool word. Is that where they come, or where that comes from? The occult. It's associate. I don't know. It's strange.
I'm not sure. I was, cause I was looking it up, and there are a lot of definitions for that word.
Yeah.
It also has to do with mystical things.
I feel like maybe not in reality they're related, but I think superstitiously the position of the moon superimposing itself over a star body is probably sort of a supernatural event. I wonder if that's kind of why those ideas are sort of tied together. I was wondering. In nouns. It's cool. But that'll be coming up, I think, on the 20th. On the night of the 20th is going to be, the 19th. I'm so glad that I looked at my little notes. It's going to be the moon occults Aldebaran on the 19th, and then the morning of the 20th is when we are first able to see Mercury.
That'll be really cool. All 5 of them.
Yeah. So it's coming up this week. That'll be fun.
What time should we go out in the morning on the 20th to see everything?
Yeah, that's a good question. I think sunrise is just about 7 a.m. right now. The brightest that it gets before you're not going to be able to see Saturn or Mercury is probably going to be just before 7 a.m. So, and that's sort of West Coast 45th parallel time. Might be different other places. But yeah, I think for you'll probably have to check your local listings for civil twilight. But I think for us, it's probably going to be between 6:30 and 7 a.m. It's going to be our best time to get some observations. It's tough though, because for morning observations of Mercury, you're really fighting if it's risen yet, right? Because you won't be able to notice. See, the cool thing about the evening is that if it's up, the sky gets dark and you're able to see it. It reveals itself. But as the morning comes about, you haven't found it yet, and it's getting brighter. It's going to get more difficult as the time goes on. And so if it's real close to the horizon, you might never actually get to see it because you won't identify its location before it just gets too bright and it gets kind of washed out with everything else. So it's tough. It can be a little challenging to find in the morning, but it'll be fun. We should try it.
It'll be fun. I'm excited to see them all together.
I think it would be pretty cool. Well, I think that wraps up most everything that we have to say for this episode of the Night Sky Podcast. Marina, I want to say thank you very much for joining me and work with me a little bit to talk about this week's sky. Sky Watching News.
Thanks, Billy.
I appreciate it. Well, on behalf of Marina Hanson, my name is Billy Newman, and thank you for listening to this episode of the Night Sky Podcast.